Hi, good morning. I'm Atul Agarwal from Neuman Esser, India. Uh, we are a 100% subsidiary of a German company called Neuman Esser Group from Germany. We call ourselves hydrogen experts. And as Dr. Gupta just said, yes, there are a lot of challenges. Generation of hydrogen is definitely a big challenge right now, and there are no proven technologies except calling electrolyzers, but all these electrolyzers are of very small capacities. And hydrogen also poses a challenge in terms of very high calorific values, but very light gas. So here we come in with our compressors, which can compress the hydrogen up to 1000 bars and even more. And we have supplied these compressors. So I'll take you a journey on our experience and what Neuman Esser is. But surely hydrogen is, I don't think we've heard the final in our hydrogen journey till now. As you said, storage, we don't handle storage, we only compress. So I compress it for you, we'll have to find storage. Yeah, but as I said, the final has not been heard on hydrogen and generation itself, as you said, is now proven technologies other than calling it electrolyzer, but electrolyzers of large capacities are still not available, still being developed by various countries, including us. So Neuman Esser started its journey, as many family-held companies in Germany are, started its journey in 1830. It's almost 200-year-old company. We developed our first mobile compressors end of 1800s and beginning, and then this company was taken over by the Peters family in 1891, so which is more than 125 years old. We shifted to our present place in Oberpallenberg in Germany, which is about 40 kilometers from the city of Aachen. And then we started supplying compressors to various users like Shell. We supplied compressors for Ariane rocket, which is a famous one where a lot of InSat satellites were also launched aboard Ariane rockets. We started our internationalizing journey. Most of the German companies are very conservative, and they started internationalizing and establishing subsidiaries in various parts of the world, including India, somewhere close to 1892 or 1992. And then we bought over during the unification of Germany. We bought our company from Mafa Wurzeln within the eastern part of Germany. Then we established another company in the eastern part of Germany called Staskol. Again, a legacy manufacturer of piston and packing rings in the eastern part of Germany, which was taken over by us. And then the first signs of hydrogen filling started in Germany. They started experimenting with it. Beginning of 2000, end of 1990s. So first filling station was established with our compressors. We took over a high pressure compressor manufacturer called Hofer in 2015. And since then has been a great journey, because the hydrogen started coming up, becoming a mainstream fuel, and people started exploring various options of how to handle this. And there, wherein Hofer comes in, fits in very well, because they make compressors not only up to 1000 bar, but even up to 10,000 bar with the hydraulic piston drives. So here we are. So this is this one Mr. Neuman and one Mr. Esser established this company in 1830 in Germany. Was taken over by Peters family in 1891, and the fourth generation of the family, brother and sister, Mr. Stephanie and Mr. Alexander Peters, are the managing partners who are responsible for running the company on a day-to-day basis. In fact, she is visiting India in next 2 days, and but she couldn't come here. She was slated to come here earlier, and we are present in 10 countries, 10 strategic countries, and 29 companies all over the place. So you will find us virtually in all the continents except Australia. We are in India, we are present in Pune. We have 5 business units. Compressor Solutions happens to be the biggest and the oldest. Then we have Sealing Solutions through Staskol. We also have mills, grinding mills. Anything which is brittle and which can be broken can be ground. So a lot of minerals are ground using this, including now the tire recycling. The tires are also recycled and by grinding. So these machines are used. You there are different kind of machines called pendulum roller mills and classifier mills. Then we have a digital solution which is in keeping with the times where everything is getting digitalized. We make process digitalized and monitor through various digital solutions. We also have now energy solutions as the energy mix is changing and we are moving towards hydrogen and green forms of energy. We have established a new division called Energy Solutions, where these compressors are used in various oil and gas applications, transportation, hydrogen, regasification, liquefaction till now, and refinery and petrochemical, which happens to our biggest market till date. With hydrogen and circular economy coming up, we use our compressors for energy and synthetic fuels, renewables and recycling, mobility and logistics. There are various applications in this, and building and industry. How Neuman Esser is present in various parts of the new hydrogen economy and the value chain. So as you see, Arcanum is a part of Neuman Esser group and it produces biofuels. These are mostly German-focused operations. Then we have Hydron, which is a recently acquired electrolyzer manufacturing company in Brazil, and we are now internationalizing their operations, including in India and Germany and other parts of the world. We are developing a larger size of electrolyzers. We started with small ones, now we are manufacturing 1.3 megawatt, and then we have plans to make 5 megawatt electrolyzers. Then we have traditional NIA business of compressors, which is used to compress biofuels, which is used to compress hydrogen, which is produced through Hydron electrolyzers. Then it is used to produce or store hydrogen gas in caverns. Then we have offer for high pressure hydrogen applications and various other gases as well. And then we have Arcanum AE Mobility, which produces fuel cells for increasing the range of vehicles. So some of the first what we have done in Neuman Esser group is cabs for Paris, which are running on hydrogen, being compressed through Neuman Esser and Hofer compressors, which are diaphragm type. Then we have project in Switzerland for hydrogen Hyundai trucks filled with hydrogen. We have green hydrogen and CO2 converted to synthetic gas, H2 hydrogen feeding in the gas grid. We have almost 100 hydrogen refueling stations established with Neuman Esser and Hofer compressors. So various applications and where we are already present. These are some of the companies in energy solutions vertical. We have alternate energy driven solutions, which makes fuel cells for range extension of vehicles. We have partnered with Contron AG Germany for using in their trucks. Arcanum Energy produces biofuels for various applications. They're already doing that work for many years in Germany and was acquired by us about 5 years back. Hydron was acquired in 2020. It's a Brazilian company and we are internationalizing this. And then we have NIA Greens, which will house most of our renewable energy and hydrogen economy business. So, how does NIA Group meets this challenge of new hydrogen economy? So, we have hydrogen and gas grid. As Dr. Gupta just said, yes, hydrogen can be produced, but it's very difficult to transport in meaningful ways to have enough calorific value to be used for various fuels. Pressure is definitely a challenge. So till now we had CNG, which was compressed till about 20 bar, 25 bar and transported, not filled in the tanks. Obviously the tanks were filled with 250 bar. But now hydrogen with its lower calorific value or very light gas. Calorific value obviously per kg is pretty high, but in terms of volume, it requires a huge volume at low pressures. So unless we increase the pressure, we cannot transport the hydrogen meaningfully across distances. We also support in synthetic fuels. And our collaboration called Infinium is producing a process to develop synthetic fuels. Bio-LNG for long distance traffic, because as I said, hydrogen is very difficult to store in large quantities. So maybe it makes sense to use hydrogen for local travel, but for large distance travel and high energy intensive travel like trucks, hydrogen seems a little difficult at this moment unless we find ways to store it at very high pressures beyond 1000 bar. Fuel cell vehicles, they are already there on the road, but again range anxiety and range is an issue because of hydrogen quantity which you can store. So we are finding solutions and working with our partners. And electrolyzers, we are planning to produce electrolyzers not only in Brazil but in Germany and India as well. And this will produce hydrogen, but all this will come up after the and for everybody to know that unless we have sufficient amount of cheap power available, we cannot produce hydrogen, and that remains a challenge as of now. But a lot of Indian players as well as players internationally are planning to establish low-cost solar photovoltaic power plants to produce hydrogen cheaply. Just to illustrate how difficult it is, but we are present. If hydrogen is available, we can compress it for you. And hydrogen compression just takes about 1.5% of the total power which is there in hydrogen. And we have been doing this hydrogen compressors for various refineries and petrochemical plants for many years now, and the solutions are available with us. We just need the hydrogen. So this is a hydrogen gas filling station compressors in Munich, and this is discharge pressure is 400 bar. Again, experimental, and some experimental cars which are vehicles which are produced were filled with this at this station. This is the diaphragm compressors which can compress up to 3000 bar or even more, and then beyond that we have hydraulic compressors which can go up to 10,000 bars, and though they are export controlled at this moment from Germany, but they have been supplied to a lot of stations in Korea, which is probably the first ones to establish these stations in their country. And 200 of these units are working worldwide on various applications, including hydrogen. This is hydrogen generation electrolyzer and reformer from our subsidiary called Hydron. It's all there. We have produced them. We know how to make them. We are increasing the sizes. So this is a typical 5 megawatt plant structure. We have the designs, and as soon as we have some orders, we are talking to people all over the world, and we will be able to produce these. You can see 2 containers housing the hydrogen generation through PEM electrolyzer. This is how it looks. This is a 2 megawatt plant which can be housed in one single container, 40 feet container. So this is what Neuman Esser is. Some fun facts with hydrogen. As hydrogen, everybody knows is going to come in, but how difficult it is and what challenges are there. Maybe I can show this. Yes, hydrogen per kg caloric value or energy value is pretty high, but it requires a huge amount of volume to store this 1 kg of hydrogen as compared to any other gas which we use, like CNG. At 250 bar we can do a huge amount of calorific value or energy value of 3038 kilowatt hours. But with hydrogen, we can do even more. The problem is how to store this. And H2 at 700 bar, it can give you energy value of 1271 kilowatt hours. But it requires a pressure of 700 bar, and which is just 1/3 of CNG. You can see it. So if you see this, Uh, Liquid hydrogen, it can give you only 2378 kilowatt hours per kg or per meter cube. Per kg it is 33. These are all 1 kg units. So at various pressures, you can see per meter cube, the moment we increase pressure to 2000 bar, more than 2000 bar, it gives you 2378 kilowatt hours, whereas CNG at 250 bar can give you 3000. So the challenge with hydrogen is we get very little calorific value or energy value even at very high pressures. So the amount of CNG which we can store is far more than what we can do with hydrogen. So if I go from here to Agra, I need to fill up my tank and again fill it up while coming back. Whereas with this hydrogen, you will need much more larger quantities of hydrogen. So range anxiety will be there while using this. And you can see similarly for diesel and gasoline, how dense they are and how energy dense they are. So for per meter cube, basically what we have a limited amount of space available, not the weight, but limited amount of space available in a vehicle like a car. We already did test having a CNG tank in a car. Now with hydrogen, we will require even bigger and larger sizes of tanks to store the same amount of energy. Slide. So very low calorific value, but even lower calorific value per meter cube of the gas at any pressures. And this is the major problem, which I am sure in this conference others will be able to handle it better. We are not the hydrogen storage guys, we are the hydrogen transportation guys. We can give you at a pressure, but pressure has its own limitations. A reciprocating compressor can do easily about 300 to 350 bar, but beyond that there are challenges for high volumes. Low volumes, of course, as I said, diaphragm type of compressors from Hopper can do it, but the volumes are very low, and there are no other proven technologies till date to handle high volume and high pressures.